Today's topic is permutation and combination. Before starting permutation and combination, you must know what is the difference between these two words, and then I will explain permutation and combination individually. Permutation, combination. Permutation means order is important. Order matters. Order is not important. What is the meaning of order is important and order is not important? For example, if I say I have to announce three position holders' name, and order is, for example, A got third position, B got second position, and C got first position. And I have to announce according to the order. First, I have to announce third position, and then second position, and the first position. If I change this order, obviously A will get the first position or C might get the second position. So order matters. But if I have to announce, for example, three students, and we are just giving them consolation prize or appreciation prize, I have to name them. For example, if I say three students are given consolation prize, so order is not important. I can name first A, B or C. Similarly, in mathematics, in some conditions, order is important. For example, if I say this is coordinate 2, 3. In coordinate geometry, we use, in graph we use, this is X, this is Y. First, always X. Second, always Y. So if I change this, if I write 3, 2, the whole thing will be changed. X will be 3 here and Y will be 2. So order matters. But in contrast, in some cases, in sets, we have a set which has element 1, 2, 3. I can write this like this, first 2 and then 1 or 3. No difference between this set and this set. Both are equal because order is not important. Similarly, if we are having 4 teams, they are participating in a tournament, and before the tournament we can write their names in any order. For example, if we have 4 teams, A, B, C, D, we can write their name in any order. For example, we can say B, C, D in A are participating in a tournament. We can name D first or we can write C first, no problem at all. Order is not important. But once tournament is finished, now we have to write down their position like this, first position, second position in order. So suppose B got first position, C got second position, D got third position and A got fourth position. Now order is important. I have to call first, for example, first position B, C, D and A. Here order is important and here order is not important. So in practical cases, some cases order important and some cases order is not important. If order is important, that is called permutation. If order is not important, that is called combination. Now I am coming to permutation only. The next lecture I will explain combination. I am just confining myself to this permutation, that is order is important. What is the key word? How can we judge the question belongs to combination or permutation? The key word is arrangement. If this word is there, and how many ways we can arrange, how many arrangements are possible, what is the number of arrangement in this sequence? So if the word arrange, then it is permutation. And what is the meaning of permutation? What is the meaning of arrangement? That is belongs to counting problems. Counting problems. What is the meaning of counting problem? For example, if I say we have one object A, in how many ways we can arrange this object? Only one way, that is A. If we have two objects A and B, in In how many ways we can arrange these two objects? First A, then B, or B and A. So one object we can arrange in one way, but if we have two objects we can arrange in two ways, AB or BA. What about if we have three objects, A, B and C? You can arrange in A, B, C or A, C, B or B, A, C or B, C, A or C, A, B or C, B, A. All these are unique order. And no order is repeating. This is A, B, C and then A, C, B like this. So in this way, if we have three objects, in how many ways we can arrange them, that is number of arrangement. If I write number of arrangement, that is 1, number of arrangement, that is 2, and number of arrangement you can count, that is 6. So what is the formula we can have for this? Look at this one. If we have one object, we can write in one way. If we have two objects, we can write 2 into 1, that is 2. If we have three objects, we can write 3 into 2 into 1, that is 3. If we have four objects, what will happen if we have four objects? A, B, C, D. It is very difficult to write because we have many options. That is A, B, C, D, A, B, D, C, and then we have to shuffle C and we have to shuffle then D, etc., etc. 4 objects. So how we can just understand this? If we have 4 objects, then 4 into 3 into 2 into 1, that is 4 3 is 12 into 2 24. The 24 will be there. So if we have one object, we can arrange in one way. If we have two objects, we can arrange in two ways. If we have three objects, we can arrange 3 into 2 into 1, that is in 6 ways. You can count 1 2 3 4 5 6. And if we have 4 objects, we can arrange in 4 into 3 into 2 into 1, that equals to 24. So the formula for this arrangement we have, if we have 5 objects, we can arrange in 5 into 4 into 3 into 2 into 1. And that is counting reverse order and multiplying is called factorial. So we can say if we have n objects, then how many ways we can arrange n factorial. If we have 5 objects, 5 factorial, 2 objects, 2 factorial, 3 objects, 3 factorial, 4 objects, 4 factorial, and in this way we can do this one. Another way to understand this counting problem, in how many ways we can arrange, let me take with one very interesting example. Suppose we have 1, 2, 3, 4 chairs and 4 students are there. Name A, B, C and D. I call one student at a time. Suppose I call A and I tell him to sit one of these 4 chairs. Suppose he select this one. So how many options first person have? How many options first person have? That is 1, 2, 3, 4. First person, suppose I want to fill this, then I just call A. A has 4 options. So once he filled this, then I called B. Suppose A filled this one. Then I called B. B has now 3 options. 1, 2, 3. Suppose we select this. How many options B had? 3. Now I called C. C has how many left? That is 2. 2 options, and then it is the meaning of arrangement. That how many possibilities are there? We have to write down this first and then multiply, multiply and multiply. In this way, that is 24. In 24 ways we can arrange 4 students in 4 chairs. Suppose we have 4 chairs and we have 4 students. So I can call one student, he has 4 options, just select one, sit, and then I call second one, he has 3 options, and then I call third one, he has 2 options, and the last one, he has only 1 option. So this is called the counting problem. And the first formula we deduce from this, that is permutation or arrangement of all n objects. Suppose we have n objects, is n factorial. As you know, 4 into 3 into 2 into 1 equals to 4 factorial. 3 into 2 into 1 is 3 factorial. Similarly, we have n factorial. But suppose if we want to arrange not all students, suppose we have 2 chairs. Suppose we have 2 chairs.